Okay, everybody. Now we're going to section 2.2, which is an extremely important concept in calculus called the derivative. That's, well, as you'll see, this is like big. So let's get down and dirty. Let's see how this derivative stuff works. So here, let's take an example. We have a graph. We have a function y equals x squared, and that's the graph of it. Of course, we often will write it f of x equals x squared. So whether you write y equals f of x, y equals x squared, or f of x equals x squared, same thing. I want to erase that a little bit, make it a little bit nicer. So f of x equals x squared. Now, I'm going to draw that roughly what that is. Again, this is just being done by hand. And I want to look at a certain point here. And we'll just call that point, I'm just going to call it x. Just take a random x value. And I want to find the tangent to the parabola. Actually, you know what I'm going to do? I'm going to change that. I'm going to change that to a different color, make it stand out, make it pop a little more. Let's make that a different color. Oh, that's horrible. That is not good. Let me just fix that. Let's just fix that. Okay, let's tangent. Okay, so it's a nice tangent, and it hits right here. That's x, and this is, of course, f of x, which is, this is f of x. And of course, we know f of x is equal to x squared because we have a parabola here. And now I want to find the slope of this tangent. So here's what I'm going to do. I'm going to do something very sneaky here. I'm going to look at this point. Let's say look at a point like right up here. And I want to look at the line that connects these 2 points. This line, as you know, is a secant line. Now I'm going to call this distance here h. And therefore, this point here, this x value here is x plus h, which means this here is f of x plus h. Well, the slope of the secant line, the slope of that secant is equal to f of x plus h minus f of x over x plus h minus h, minus x. Minus x. And so now, this, of course, the x's cancel, and I just going to be left with an h on the bottom. So this is really, so the slope is going to be equal to x plus h squared minus x squared over h. And we're gonna deal with that. Now imagine I would take here closer. Let's say I would take a secant that's even closer to the original. So the secant that I'm going to look at now, if I go to, let's say, to this point, if I move to this point, so I'm gonna draw that secant. Now, if you notice that the new secant is closer to the blue tangent. So I have the red secant, and then I have the purple secant. But because this difference, this really the new h value, I should say, h is the difference between the x value of my tangent point and the x value over here. So since that h is getting smaller and smaller, this tangent, the purple tangent, sort of collapses onto the blue tangent, and the slope, therefore, the slope of the blue tangent is, drumroll please, m is going to be equal to, ready for this, folks, the limit as h goes to 0 of x plus h squared minus x squared over h. Now let's work this out. This is equal to the limit as x goes to 0 h goes to 0. The limit is h goes to 0 of x squared plus 2xh plus h squared minus x squared over h. What did I do here? I just took this this guy here and I expanded the binomial. Now notice I have an x squared and I have a minus x squared. So this is now all equal to the limit as h goes to 0 of, now I'm going to factor out an h times 2x plus h over h. And if you notice how beautifully these two h's cancel, this is now equal to the limit as h goes to 0 of 2x plus h over 1. Now, when h goes to 0, basically this guy here just disappears. So this is equal to 2x. And that is my answer, 2x. Let me just, again, the 2 and the x are touching. So wow, why am I making this so close? 2x. Okay. And so the way we write it, we write f prime of x is equal to 2x. That's how we write. And I'm going to take all of this and I'm going to put it into, I'm going to copy, let's just, and we write in general that f prime of x, that's the derivative, is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Now, if you notice, this is one of these guys where the bottom is clearly going to 0 because h is becoming 0. The top is also going to 0 because when h becomes 0, it becomes, as h goes to 0, this would be f of x minus f of x. You see what I'm saying? So when if I would just plug in h equals 0, I get 0 on top, 0 on the bottom, and therefore you can't just plug in x equals 0, h equals 0. You gotta work with this. So first, let me just copy this. Else. And this is the definition of a derivative. This is really the definition of a derivative. So the derivative is f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. And that is how it is, and that is how it works. What I'm showing you here is actually in the textbook, which is in which you can click on in section 2.2 in MyOpenMath. Anyway, but let's just go through it. The derivative now, so the derivative of a function f at a point of x comma f of x is the instantaneous rate of change. Remember we talked about I can figure out my average rate going from here to San Francisco, but I how do you figure out the rate at the instantaneous rate at any particular point? So that's something we use derivatives for. Isn't that cool? And the derivative is the slope of the tangent line to a graph, which is what I just demonstrated with our little parabola. The derivative is the slope of the curve f of x at the point x comma f of x. Slope of the curve, slope of the tangent is really the same thing. And a function is called differentiable if the derivative exists at you can say it's differentiable at a point, it's differentiable on an interval, you can say it's differentiable everywhere, and that depends on the situation. All those things are possible depending on what it is or isn't. Now here's where it gets a little here's where I get a little historical here, not hysterical, but historical. There was someone named Newton, Isaac Newton. I may have heard of him. I think he invented the fig. I get it, Fig Newton. And he is famous for having invented calculus. That's because that's what people say if you're from England. If you're from Germany, you would say that Leibniz invented calculus. Truth is that each of them invented parts of it, or each of them invented independently almost all of it, and they again, it's different now. Nowadays, you have telephones and now you have telephones and email and all kinds of internet and all this kind of stuff. But back then, if people in different countries, communication, it was kind of isolated from each other. Anyway, they both developed calculus, but they used different notation. Whereas one, I believe Newton would write f prime of x, which is the way I wrote it on the page, or he'd write y prime, which is similar to what I wrote. Leibniz would write dy dx. That's how you read it. That's how you read it. Dy dx, or you say df dx. Y, because y equals f of x, and y and f are the same thing. So the fraction notation is the Leibniz notation, and that's the way it is. Now, what's good about the Leibniz notation, it's a little clunkier, but it does remind us a little bit more of delta y over delta x, which is the slope. So that's a good thing. So you say we find a derivative, take a derivative, differentiate a function. This is just different ways that we say what we're doing here. And the formal algebra definition is this is really what I tried very hard to write by hand. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. This is something, tattoo this into your brains, because the truth is, even if you don't tattoo it into your brains, it'll get tattooed, because we're gonna be doing this over and over and over and over again. You're gonna see this quite a bit. And the practical definition is the derivative can be approximated by looking at an average rate of change, which I said is that secant line, or the slope of a secant line over a very tiny interval. The tinier the interval, the closer this is to the true instantaneous rate of change, slope of the tangent line, or slope of the curve. So that's what I said. This is really what I was talking about before, when I had the red secant and the purple secant, and the secants are getting closer and closer to that blue tangent. And what we're going to do from this point on is that we're going to find techniques of how to find a derivative. Now, but one thing I didn't tell you is let's go back to the example we were looking at before. Let's go back to the example we were looking at before. So we had this over here. In the example we did over here, so we said f prime is 2x, but the question is, at the point 1, this point, let's say looking at a parabola at the point 1, comma 1. So what is the slope of the tangent? So let me see if I could, I'm going to try to redraw this whole definition. And I'm going to try to, redraw this whole picture here. So you have a parabola. So we have a parabola now. And it's, y equals x squared. Y equals x squared. And we want to know at the point, at the point, we're over here. At this point, again, I'm a very horrible artist here. So at the point 1, comma 1, so it's the point 1, comma 1, what is the slope of the tangent line? If I would draw, let's do my blue tangent. So if I'm going to draw and again, I'm very bad at drawing, but bear with me. So here is my blue tangent. What is the slope? Well, the slope, or this actually, let me write it this way. The slope is going to be equal to f prime of 1. Why 1? Because it's when x equals 1. And that's equal to 2 times 1. Because we know that f prime in general is 2x. We figured that out already for this particular function. And now, so m equals 2. Now, what is the equation? Well, actually, we'll get to that later. Let's go to a point up here. Let's say this is the point. Another color. Let's say here's a point where x equals 3. If x equals 3, we know that y equals 9. But what is the slope for that point? Well, the slope is going to be f prime of 3, not f prime of 9, but f prime of 3. So it's going to equal to 2 times 3, which of course equals 6. So the slope of this tangent is 6. The slope of the blue tangent is 2. We see that right here, and which makes sense because the parabola is curving upwards, so the slope sort of keeps on going higher, steeper, I guess. And that is how we actually practically find the slope. Now how did I know I could just is the slope always just twice the x value? No. That's this particular function, because when we worked it out, when we did the math, we got let's try that. We got f prime of x, I'm just writing, was equal to 2x. That was what we got when we worked it out. We worked out all that algebra. We did all that limits and canceled stuff, and we got down to 2x. So that's not always going to be the case, but it is the case right now. Let's say we want to find we have the function f of x equals x cubed, x to the third power, and we want to find the derivative. Well, we're going to go like this. We're going to say it's equal to the limit as h goes to 0 of x plus h to the third power minus x to the third power over h. Now, where did this x plus h to the third power come from? That is, this is f of x plus h minus f of x. Because f of x plus h is x plus h to the third power. F of x is x to the third power. Let's go back to the color to start with. Now this is equal to, if we just write this all out, I'm going to move this. So this is equal to the limit as h goes to 0 of, I have to expand this out. So this is x to the third power plus 3 x squared h plus 3 x h squared plus h to the third power, and then minus x cubed, because that comes at the end, minus x cubed. This is all over h. Now the x cubes cancel out. And I'm going to rewrite this now as the limit as h goes to 0 of, now I'm also going to do another step. I'm factoring out all the h's. Or factoring out one h, I should say, not all of them, just one h. And I'm left with 3x squared plus 3xh plus h squared. Well, that's over h. And and finally, not finally, but now I have an h here and an h there that cancel. So this is equal to the limit as h goes to 0 of, there's just a 1 on the bottom, 3x squared plus 3xh plus h squared. Now, as when h goes to 0, at this point, we explained that when you have limits, we finally got the limit down to a point where I could just plug in 0 for h, and I don't have any problem of 0 over 0. So if I just put in 0 for h, that guy disappears, and I'm left with, my final answer is 3x squared. And that is the derivative, that is f prime of x. By the way, notice I wrote limit, 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 limit. It wasn't until this very last step that I finally stopped writing the word limit, because I never actually exercised the limit. In other words, so here's the definition: x plus h to the third minus x to the third. Now I just did now I'm doing a whole bunch of algebra steps. I'm not even doing the limit yet. So I got rid of, I canceled out the x cubes, I factored out the h, I canceled out those h's top and bottom. Now it's finally at this last step that I actually exercised the limit. I actually applied the limit. I don't know what the right word is. I think apply is the right word. I actually apply the limit. But when I apply the limit, that's when these last two terms here, the h and the h squared, disappear. And I'm just left with 3x squared pound. That's my answer. So my answer is the limit f prime, let me just write it down here. F prime, so f prime of x equals 3x squared. So if f of x is equal to x to the third, f prime of x is equal to 3x squared. And that is how we find that. That was a very nice example. Let's see, I think I'm gonna do one more and that'll be it for this video. Let's do another example. Let's do, so I'm gonna write here example. Let's do f of x equals 1 over x. Well, f prime of x, that's going to be equal to, well, it's f of x plus h. So that's 1 over x plus h minus 1 over x over h. Now, again, and what did I not write here? I had to write the limit. So it's the limit as h goes to 0 of 1 over x plus h minus 1 over x over h. Now let's do a little bit of algebra. I'm going to combine these two fractions. So let's do a little. So what I'm going to do is I'm going to multiply one of them. I'm going to multiply this one here by x over x. I'm going to multiply this one here by x plus h over x plus h. And that's going to give me, let's go back to my, okay, that's going to give me, so again, I didn't actually apply the limit. I haven't spent the limit, so to speak. So it's all I've done really is just algebra. So what I have here is I have x plus h is my common denominator, and I have x minus x plus h is my numerator. And this is equal to, I can sort of combine this. You see, I have a fraction over an h. So basically this h winds up going onto the bottom of that fraction. Let me just rewrite the whole thing. This is equal to, I put the equal sign there. So this is equal to the limit as h goes to 0 of x minus x plus h over h times x plus h. Now again, I'm still just doing I'm still doing more algebra now. The reason I'm still writing the limit is because I'm not ready to take the limit yet. See, when you take the limit, then you're going to get the answer is whatever. You won't write limit. You won't keep on writing limit. I haven't taken the limit yet. All I'm doing is just algebra. So now what I'm doing is I'm just going to, this is just x minus h over x plus h. And if you notice, these two x's here just cancel, just unceremoniously cancel. And this is equal to the limit as h goes to 0 of negative h over h times x plus h. And I'm canceling out the h's. Now, because if you cancel out, you get a 1 up here. So this is equal to I'm gonna have to go down. This is equal to the limit as h goes to 0 of negative 1 over x. Oh, I lost an x. I have to apologize. I lost an x. Just fix that before I go on. And that is, there was an x there and I just forgot. There was an x there and I just forgot to draw it. Oops, no, I have to shoot my screen. Brush, okay. So this is hx, and now the h is canceled. So I have x times x plus h. Now finally I can apply the limit, and I'm at a situation now where if I would just plug in h equals 0, I got no problem. It's just negative 1 over x squared, and that's our final answer. So f prime of x is equal to negative 1 over x squared. And that is a thing of beauty. I'm going to write it up here. F prime of x equals negative 1 over x squared. That is a beautiful thing. Okay, and that really concludes this video. I just need to do one thing. I want to put this into our scroll here. There we go. That concludes today's video. It's been loads of fun, and we'll see you next time.